So in order to transform it, in order to make it become like this, we have to try to divide the first row by 1/2 to make the x become 1. So in order to express it using the elementary row operation, we are going to write like this. Now, in the previous video, I already showed you guys how to solve the system of linear equation in 3 variables using the substitution and elimination method. And in this video, I will show you guys how to solve the system of linear equation in 3 variables using something called the Gaussian elimination. So in order to use the Gaussian elimination, we have to convert the system of linear equation in 3 variables into an augmented matrix, and then we will reduce the augmented matrix into its row echelon form using elementary row operations, and then we are going to extract and then we are going to express the system of equation from the row echelon form, and then we are going to solve for x, y, and z. So that's how you are going to solve it using the Gaussian elimination. So in order to apply the Gaussian elimination, the first step you have to do is you have to express this system of linear equation in form of augmented matrix. So how to form is that you see this the coefficient of x and the coefficient of y and the coefficient of z and the real number right here. So we are going to fill this into a matrix. So I will get something like this. So this column is for x, this column is for y, and this column is for z, and then we are going to divide this. We are going to have a real number, and the real number means this one. This is we are going to fill right here, and then we are going to close bracket. Now we are going to fill in the x. So what does the column? Each entry in the matrix on here is basically the coefficient of x, y, and z corresponding. So from the first equation, the coefficient of x is 2. For y is 1. For the z is 3. And the real number is, the constant is 2. And we are just going to keep filling for each of the equation. We are just going to do it repeatedly. So for this one is 4, 2, 5, 1, and 5, 3, 6, 3. And then we are going to reduce. Now we have already expressed it in form of augmented matrix, and what we're going to do is we are going to transform the augmented matrix into its row echelon form using the elementary row operation, and that is the longest and the hardest part about the Gaussian elimination, because you have to try to think a way such that you will get the row echelon form. But not all system of linear equation will end up in row echelon form. Because if it's end up in row echelon form, then we get a unique solution. But if it's not, we have two cases. One is the coefficient of x, y, and z is 0, or the row consists of all zeros. If only x, y, and z has 0, then we will get a no solution. But if you have But if a row consists of all zeros, changing the coefficient of x, y, and z, and the constant on the other side is consists of all zeros, you will get an infinite solution. So we are going to try to transform this into to its row echelon form using the elementary row operation. So in order to do that, we are going to transform the 2, we are going to divide by 2 for the first row. That's because if you guys know what is the row echelon form, basically they want you to reduce the augmented matrix in form of like this. You have the diagonal 1 1 1 and then 0 0 0, and they have A, B, C, and then D, E, F. So this is how the row echelon form will look like. So in order to transform this, in order to make it become like this, we have to try to divide the first row by 1/2 to make the x become 1. So in order to express it using the elementary row operation, we are going to write like this. So 1/2 row 1. So if you don't know what was this, the R sub n means the nth row. Nth row over matrix. So we are going to take the row 1, divide 1/2, and then we are going to back to row 1. So our result is something like this. So 1/2, 3/2, and then 1. And then just copy the rest, because we only take row 1, not take the other row. And then we are going to make this 4 and 5 become 0, because as you guys can see the row echelon form right here. So in order to do that, we are going to take the row 2 minus 4 times row 1, and at the same time row 3 minus 5 times row 1, because I purposely do that to make this one become 0. So row 1, row 2, minus 4, row 1, back to row 2, and row 3, minus 5, row 1, back to row 3. And we are just going to copy down the first row, because we are not involving the first row. But we are going to we are going to change the first row we are going to change the second row and the third row. So we are just going to plug this 0, because as I said, we are purposely doing that such that we will make this one become 0 in order to transform it into its row echelon form. And then the rest, take your time and do it yourself. So you're just basically doing like row 2 minus 4 times row 1, so it will get 0. Something like that. If like row 3 minus 5 times row 1, then you will have 1/2. So you're just doing this like keep doing this until you will get something like this. And after doing that, there is actually one problem. That is the second column. The second column, in the middle of this 3 by 3 coefficient matrix, it's just 0, but we don't have 1. So in order to do that, we are going to swap row 3 and row 2. This is the only option. We cannot swap row 1 and row 2. That's because if we swap row 1 and row 2, the 1 will going down here, which will not meet the row echelon form. So to do that, I'm just going to swap the row 3 and row 2. So row 2 and row 3 swap together, I will have something like this. So row 1 still copy, we still copy the row 1, but we are going to switch the row 2 and row 3 So now, so we already swap, and then what we can see here is the middle one. We have to make sure that it's equal to 1, but this is 1 over 2. So we just going to multiply 2 to here in order to make this become 1. So row 2 times row 2 back to row 2. And then here is the final step. Look at the bottom row. In order to meet its rotational form, I have to make sure that for the third column, the bottom one has to be equal to 1. So in order to do that, we are just going to multiply row 3 by -1 and then back to row 3. So this is our final result. We have already met the raw echelon form because we got a diagonal one. The lower triangle is filled with 0 and the upper triangle is filled with constant. That's good. Even though it's filled with 0, it's also good. And then beside it is also constant, but even though it's all 0, it's also good because as long as it has diagonal 1 and it has and the bottom at the lower of the diagonal 1 is filled with 0. So this is what we call the raw echelon form. And then we are going to express this new raw echelon form, the augmented matrix, into the system of linear equation. Why? Because you will see something really good later. So we are going to express this one out. So I will have x plus y over 2 plus 3z over 2 is equal to 1. And remember, this is x, this is y, this is z, this is the constant. So we're just going to express it out. And then y minus 3z is equal to -4. And z is equal to 3. So we are going to plug this z equal to 3 into this equation. So I have y minus 3 times 3 is equal to -4. Then y is equal to -4 plus 9, which is equal to 5. And then we are going to plug the value of y and z into this equation to find the x. So x plus 5 over 2 plus 9 over 2 is equal to 1. And then we're just going to take this whole thing to other side. So x is equal to 1 minus 5 over 2 minus 9 over 2, which is x is equal to -6, and we are done. So this is how simple the Gaussian elimination. But the hardest part and the longest part is to try to transform the augmented matrix into the raw echelon form, if possible, using elementary row operation. So this process is quite long, but it's worth to try. So our final solution is x is equal to -6, y is equal to 5, and z is equal to 3. So this is how you solve the system of linear equation using the Gaussian elimination. And as always, if you guys enjoyed this video, leave a like and subscribe to my channel for more upcoming math videos, and I will see you guys next time.